Alright, moving on to page 380. At the top we have our key concept, which is rational numbers. Rational numbers can be written as fractions. Says this is for algebra. A over b, where a and b are both integers, but b cannot equal 0. Okay, and then we have our model. So we have whole numbers on the inside, then including negative numbers, we have our integers with our whole numbers, and then rational numbers, we have our integers and our whole numbers. So we have negatives and fractions. Alright. Terminating and repeating decimals, percents, and integers are all rational numbers. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. So that's what we did with our 1/3. So remember, we did 1/3 and we did 1 divided by 3, where our numerator is underneath and our denominator is on the outside, to figure out how to get that. So that's all they did here. We're not using calculators, we're using our brains. So 3/10 would be 3 divided by 10 to get your repeating decimal with your zeros, which means that it is a terminating decimal, so it's just 3. Because remember, these zeros aren't needed, so that's why they're saying this is terminating, because it can be ended after my 3. 4/5 is 8/10, and a bunch of zeros, we don't need those zeros, so that's why it's terminating to 8/10. Alright, then we have 5/6, which is 0.833 repeated, because we're going to have more than that, and it says it doesn't terminate, so that means there is no stopping number there. It doesn't ever have zeros at the end. Alright, so to indicate a pattern that does not repeat, or that does not terminate, which in our case is our 5/6, we have to use a bar notation. It's a bar that's placed over the digits that repeat. So sometimes maybe you've seen it with the 3s, and you've seen 3, 3, and somebody puts a bar like that. Okay, so you put the bar over the numbers that is repeating. So that's why when they had in their first example, we have 0.545454. My common pattern is the 5 4s. So that's why they put the bar over 5 4 the first time, because they know that that pattern is going to repeat 5 4 5 4 5 4 continually until forever. It's never going to stop. Okay, but when you have just one digit that's repeating, you just put it over that single digit. So like for this example, we have 0.583333 continuing. The only number that's repeating is my 3, so that bar needs to go over my very first 3. Okay, looking at the example number 1, write 5/12 as a decimal. So we have to divide my 5 by 12. I'm going to do it again so I can't look at there, so I get my practice. So my numerator goes underneath, my denominator goes on the outside, so 5 divided by 12. Okay, well I can't do that, so I need my 0 placeholder. I need to add my decimal and my zeros. Now I'm looking at 50. 12 times 4 is going to be 48, which is close to 50 without going over. I'm going to have a 2 remainder. Pull down my 0. 12 times 1 is going to get me close to 20 without going over. So then I'm going to have 8 left. Pull down my 0, so now I'm at 80, and I have 6. Then I'm going to do 72, and then I'm going to stick with my 8 again. So without even having to pull my other 0, I already know that I'm going to be stuck with 80. So my common pattern, my 6 is going to be repeating, because if I was to continue on forever, I would notice I'd have 6, 6, 6, 6, 6, 6, 6 forever and ever, and that's boring. I don't want to do that. So I'm going to put my bar notation over my last digit that's repeating, or my very first digit that's repeating, sorry, to indicate that this digit is repeating. So 5, 6 equals 0.416 with my bar notation indicating that my 6 is repeating.